video, we're going to look at a real-life example involving 6 lines of business. We're going to run the composite model for the 6 lines. Okay. And you will see that if we go to LOB4, first of all, it's quite a long tie line in the sense that there's no decay till development year 6, which means for the next 6 calendar years, you're paying a lot of money. And also, there's a lot of instability in the calendar year trends, and the trends are quite uncertain. There's a lot of uncertainty in the estimates. For instance, 14% plus minus 3, 56% plus minus 14. And that's a result of a lot of process variability. So if you look at the standard deviations of the normal distributions, even this for these development years where the numbers are pretty high, it's still 36%, 0.36. That is the standard deviation. Do we have normal distributions on a log scale? We have normal distributions. So LOB4 is the most volatile line. Let's do a forecast of the aggregate of all lines. So we could say combined conservative. And you'll see that if we go to the forecast summary and look at LOB comparisons, something that we did with Berkshire Hathaway in the previous study, you'll see that LOB4's got a huge CV, close to 50%. And LOB4 is also 11.22% in terms of mean reserves to the total reserves. So it's 11.22% of the total reserves. And it's got a pretty, whereas the CV of the aggregate is 17.14%. There's a lot of risk diversification credit by writing these almost non-correlated lines. Are there any correlations? Yes, there is. There's LOB1, LOB2, there's some process correlation. But if you look at the correlations in reserve distributions, it's pretty low. 0.14. So there's a lot of risk diversification credit here, and as a result of are there any correlations between LOBs? They're all 0 except for 1, which is pretty small, and therefore you get to see that the CV of the aggregate is tiny. If we look at the calendar years for LOB4, you notice there's a lot of correlations between the calendar years. This kind of means that if the first year's in distress, then the other years, if you've got huge losses in the first year, because of the high correlations, you're also more likely to have huge losses in the subsequent years. So for LOB4, first year in distress means that subsequent years are also more likely to be in distress, and therefore your delta TP, your additional technical provisions, will be pretty high if the first year's in distress. However, if you look at the aggregate, you'll find that the correlations are pretty low. Also for the aggregate, if you look at the calendar year distributions, by 2011, you've already paid 52% of your total reserves. So it's the next 2 years, that's where you make 52% of your payments. However, for LOB4, it's a very different picture. LOB4, wow, I mean, you've got to go to 2019 before you pay 50% of your reserves. And I try to mention the reason for that before, because if you look at LOB4, 6 years before you actually, 7 years in fact, 0 to 6, 7 years, say 6.5 on the average, before it starts decaying. You've got also a high calendar year trend. You've also got a lot of process variability. So the liability stream by calendar year is pretty flat, increases a bit, and then decays only very slowly. For the aggregate, again, very different picture. Okay, so now let me run the model again, but only forecast for LOB4 instead, combined LOB4. Now, let's now do, in the second run, why don't we look at the reserve. We're going to do 100,000 simulations of all the calendar years to calculate the unconditional VARs and BELs and so on. And then we'll take a band of 100 samples that lie in the 99.5 percentile for the next calendar year, and for each one of those, do 1,000 simulations. So we'll have another 100,000 simulations of the conditional distributions if the first year is in distress. So we need two sets of distributions. We need the unconditional, as if the first year is not in distress, and we also need the conditional distributions if the first year is in distress. So we're doing, millions and millions of simulations here. So we do the unconditional ones first. When we go to the aggregate of all the lines, I think the unconditional simulations will be 236 million from correlated log normals. Here it's about a sixth of that. That's about, about 40 million? 40 million, just under 40 million simulations for obtaining the distributions of the unconditional distributions, and you go to somewhere around the same amount of simulations for the conditional distributions. Okay, so what do we have? Let's look at the charts first. So first of all, what you notice is the total capital inception is 109 million. Okay, the delta TP, which is this blue, the delta TP is pretty large, meaning that if the first year is in distress, you need a lot of additional technical provisions for subsequent years. The VAR is pretty small compared to the delta TP. The SCR is 48 million. That's the solvency capital requirement, which is the delta TP plus the VAR. Let's just check there. The SCR is the VAR plus the delta TP, the delta TP. Let's get the color. Oops, missed. So that's the delta TP. And you can see that in our example here, it's pretty large. And that's because of huge correlations. So if you now look, these are just percentages there. So if you now see what happens, if the first year is in distress, your delta TP is, the conditional VARs are very large. Okay, the conditional VARs are very large. That means that the conditional MVMs are pretty large. Okay. So if we look at the table itself, you can see that the unconditional VARs, these are the unconditional, these are the conditional VARs, which very often are considerably larger. So these are the delta MVMs. But then you've got the delta BELs. Where are the delta BELs? Delta BEL discounted. The delta BELs are large. The delta BELs are very large. The additional mean reserve you require because of the high correlations is pretty large. Let's look at the correlations for LOB4. LOB4 calendar years correlations are very high. So if we go back to the okay, so what do we want? We want to close that. We want to go there, and we want to look at the solvency summary. So if we look at the table itself, you can see that the delta bells, these are the bells. The delta bells are very large. Okay, and you've got your delta MVMs. So let's go back to the technical provisions in the graphs. Well, it's a bit hard to tell. You've got to tell the difference in the graphs between the unconditional and the, these are the conditional VARs, MVMs, and bells. These are the unconditional. And it's hard to tell from the scale. I think one needs to look more at the tables, but the difference, the delta bells are very large, and that makes the delta TPs very large, as you can see from this picture here. This is at inception. That's the total capital unit at inception. This is what you need for calendar year 2010, and that's for the subsequent years. Okay? Well, you can see the scale. I mean, if you look at the conditional, it goes up to 20,000. Whereas you look at the unconditional, we've only got a 10,000 there. So that's a conditional mean, conditional MVM, and conditional VAR. So it's like the total amount of money you need each calendar year, and you can see the conditional numbers go up to 20,000. Whereas the unconditional only go up to 10,000. So the delta TPs are extremely large numbers. Now let's do the same simulation, but we'll do it for the aggregate of all the lines of business. So that's the first one. We'll do it for the reserve part. And of course that's going to be slower because this does about 246 unconditional simulations in the first, and then it repeats that kind of simulation, a bit fewer, maybe only about 230 million simulations for the conditional distributions. I actually paused the video, so that took about 5 to 6 minutes of around 470 million simulations from correlated log normal. So it's not a slow coach. Let me just check let me just look again at the one line of business, which is LOB 4, which was extremely volatile. If you look at year 11, you could see that this is the unconditional distribution. So the total amount of money you will need, which is the BEL, the MVM, and the VAR, is 7.491 million. Yet so it's the other way around. That's the conditional. The conditional one that has the 20 million is 7.491 million, okay? I just misread it. That's the conditional one. In other words, given that the first year is in distress. The unconditional one, you only need about 5.573 million. So you need much more money if the first year is in distress. And you can see again that the conditional VARs, these are the conditional VARs, the VAR, conditional VAR plus the MVM plus the BEL is much higher on the left if the first year is in distress. This is the unconditional distributions where the numbers, the values are much lower. Let's look at the difference in BELs. The BEL here is 3.579 million vis-a-vis 4.81 million. Well, you need much additional BELs, so the delta BELs are pretty large. But of course that can also be seen from the table itself, where you can see that the delta BELs are very large numbers. For instance, if you look at 2030, the discounted mean is 818, but the delta bell is much larger. In other words, if the first year's in distress because of huge correlations, you need much extra mean reserve for the year 2030. Now let's look at the two again, where we also look at the aggregate. This is the aggregate picture. So for the, let's look at summary. For the aggregate, the SCR is 10% of the bell, around 10-11% of the bell, whereas for the one line of business LOB4, it's 91% of the bell. Okay, for the line of business LOB4, let's just see, the VAR for 2010 is 3.92% of the SCR. That's for the LOB4, the most volatile line. So most of the SCR for the volatile line is really made up of delta technical provision, the additional technical provisions you need from the second year onwards if the first year's in distress. Well, if you look at the aggregate of all the lines of business, the delta TP is only 24% of the SCR. So just a very simple example of a very illustrative example, real data where you get credit diversification, you get risk credit diversification for writing multiple LOBs that are hardly correlated. Now let's go and look at the aggregate again. If you look at the aggregate and you look at the charts, let's just compare charts again. Well, you can see delta TP here is very small proportion of the capital you need, whereas here it's a big proportion. Let's look at percentages. So delta TP of the total capital inception is only 2.34%, whether for that single line of business it's 42%. Just remarkable. Now, the other thing which I think is quite interesting is if you look at the aggregate of all the lines of business, it's only 6 here. For the 6 lines, you're looking at SCR, which is 11%, 10 to 11% of the best estimate ability, of the mean reserves discounted. Well, that's not much in my view. 10 or 11% for 6 lines is not that much additional capital. Assuming we're doing this for 40 lines of business, I can see much more reduction. SCR might only be, provided they're not correlated or very little correlation, it might only be 3 or 4% of bell. Okay, provided they're not correlated. Now what I'd like to do is for each, the LOB4, and let's look now at each one, the aggregate and LOB4 on its own, just looking at the VARs of the aggregate now. In other words, we're going to look at capital allocation by line of business, the way we did with Berkshire Hathaway in the previous set of videos. Sorry about that, but I was just distracted by the storm outside. So let's look at capital allocation based on VAR of the aggregate. We've done 2 simulations, I don't know. I think we have. Yeah. So let's look at 99.5 percentile. If you're looking at LOB4 on its own, at 99.5%, VAR of the aggregate is 176 million. And you notice that the VAR of the aggregate is much larger than the mean. So the mean is 78.261 million. The VAR of the aggregate, the VAR for LOB4 is 76 million, 176 million. And you can see the percentage is 226%. However, if you look at the risk capital that you require at 99.5% based on the VAR of the aggregate is 188 million for all the lines of business, the 6 of them, versus 176 million. Of the 188 million, 0.465 million you would assign or allocate 111 million to LOB4, what about percentage-wise? For the aggregate, gee, this is really an indication of risk diversification credit. For the aggregate, you only need 27%. The VAR at 99.5% is only 27% of the mean reserve for the aggregate. Let's compare that with our solvency measures, more dependent on delta TPs for subsequent years and the VAR only for the first calendar year, the next calendar year. So let's just do some comparisons. Okay, this is, well, this one goes with this one, and this one goes with this one. So here, when you've looked at the aggregate, which goes with that one, the SCR is 65 million. Okay, it's 65 million. The VAR of the aggregate, well, my guess is it's much larger. It's 188 million. So it's 188 million versus 49 million. Okay, VAR of the aggregate is much larger than, so that the SCR, which is 65 million, let's read it again. The SCR is 65, the SCR is 65 million, the VAR for the next calendar year is 49 million. So the SCR, based on the 1 year risk horizon, is much less than the VAR of the aggregate, which is 188, 465 million. It's about a third. Okay? For LOB4, SCR is, we're looking at percentages. SCR is 48 million, vis-a-vis VAR of the aggregate of 176 million. Okay, so this is a great example of risk diversification credit, both based on VAR of the aggregate, also based on calculating solvency capital requirement, 1 year risk horizon, both for a single line, which is the most volatile amongst the lines, and the aggregate of 6 lines of business. And I think I also mentioned the simulation that we did, the hundreds or the millions of simulations we did, hundreds of millions, about 480 million simulations, is about 5 to 6 minutes on my computer. Okay, now we did mention that correlations in fact drive the delta TPs. If I go and look at LOB4, and this is where, no, this is not LOB4, that's the aggregate of all the lines. What did that, yes, let's go and look at LOB, I think it's the second one. Yeah, this will only forecast for LOB4. If we go to periods, now future parameters, remove parameter uncertainty. Let's exclude parameter uncertainty. If you exclude parameter uncertainty and you look at the forecast summary, you see all the correlations between calendar years are 0. So if I now do the Solvency II calculations for reserve part, all the delta T's, the delta TP should be approximately 0. Remember, this is based on simulations. Now, the reason we're doing the simulations is the system or the models forecast log normal distributions for each cell, and there's no analytical distribution, closed analytical distribution for the aggregates of log normals, so we need to simulate from all these log normals. So look at our solvency charts. It's better looking at, I guess, at the grid, and we're going to look at metrics. So you can see technical provisions, the delta technical provisions are essentially zero. There are no correlations between the calendar years. In other words, if the first year is in distress, it has no implications for subsequent years. So the additional bell, the delta bells are zero, the delta MVMs are zero, and the delta technical provisions are zero. Okay, so what really drives the correlations between the calendar years is the parameter uncertainty. The more parameter uncertainty, usually in the presence of more process variability, everything else being the same, the higher the correlations. If you remove the parameter uncertainty, then there are no correlations between the calendar years. Okay, thank you.